back to it. 3-year bond, 4% annual coupon rate, 5% yield to maturity with $1,000 face value. So starting it off, you're going to find the present value of the bond first, and you do an HP2 plus financial calculator. It's going to be way easier. So I'm just going to write down for you. It's going to be 3-year bond, so you put that in the N. 5% yield to maturity, so you put that for the IR. You're solving for the present value, and then for the annual coupon rate, it's going to be 40 with the $1,000 face value. So once you all have that, you solve for the PV. PV of the bond is 972, 760, 75. About. It could be a little bit different depending on which calculator you're using. But okay, from here, this is where the fun begins. This is where the magic happens. Cash flows start coming in. Okay, so it's 3 years, so you're going to be selling for 3, technically 4 cash flows, since you're going to be selling for maturity too. But the second step is basically to find the present value of each cash flow. So the way you do it is, so 40, at least for the first one, 40 divided by 1.05, which is basically 1 plus the yield to maturity or the discount rate. And when you do that, you get 38.0952. Now that's for the first year. Now you can do it several different ways. You can either do 40 divided by 1.05 to the second power, works as well. And then 40 divided by 1.053 works as well. Me personally, I just like to grab that number and divide it by 1.05. You get the same exact answer. So for this one, you get 36.88. I believe it's 88. Might be wrong about that. No, it's 28, sorry. 2811. For this one, you get 34.5533. Sorry, 535. Sorry, I'm a little bit dyslexic. That's okay though. So you get the 3 cash flows. Now to solve for the maturity, there's no other way to do it, at least I think so. But you do 1,000. There's actually a different way to do it. It's just easier this way. 1,000 divided by 1.05 to the third power. Don't forget, it's still the third power, it's not the fourth power. Because it's a 3-year bond, and you get the maturity at the end of the 3 years. So 1.05 to the third power, it's about 1.1576. So when you do that, you get 863.8563. And then from here, remember the present value we got from the original bond, so present value of the bond. Basically what you do is each cash flow, you divide it by the present value that you found for the bond. So it'd be divided by 972,765, divided by 972,65, divided by 972,65, and for the last one, same exact thing. And actually I will write that all out. It's pretty straightforward, but I'll give you the answer that you need for each one. So when you do that, so you do 38.0952 divided by 972.765, and this is what you're going to get for each one. So you get 0.03916 for the first one, and then you get 0.03730 for the second one. And for the third one, you get 0.03552. Not sure what's in there. And then for the last one, you get 0.8880. If you add all these up right now, you're going to get 1, and you have to time weight it. And that's the whole point of the Macaulay duration. So what you do is times 1 for the first one, times 2 for the second one, this is second year, times 3 for the third one, third year, and then times 3 for the last one where you get the bond at the maturity, it's going to be 3, 2. And then once you times these, and you have to add these all up, it's sum, you get 2.8844, and that's the Macaulay duration. 2.8844 for this problem, for the Macaulay duration, you get it. 2.8844. You're going to notice that Macaulay duration, you can never have a longer Macaulay duration than the actual bond. Same thing with modified duration. Your modified duration will never be bigger than your Macaulay duration. And that brings me to my next point, how to find modified duration. I'm just going to squeeze it in this video because it's super simple. To find modified duration, mod D, you can see it's acronym like that. It's going to be the MACD. So if the problem gives you it already, that makes it so much simpler. Or if it's like this is the first problem, then ask you for the mod D, so much simpler. Otherwise, you're going to solve it all the way through. And then some of this is, you do approximate. That's going to be for another lesson, but it depends on how your professor wants it, or your investment firm wants it, or your bond investor wants it. Really doubt they're using this equation, but you know, 2.884, that's the MACD. So you do Macaulay duration divided by 1 plus whatever the yield to maturity is in the problem. So in this case, 0.205, so 5%. And then once you do this, you get 2.7470. So that's the mod D. That's the modified duration. Super simple. Modified duration, again, will never be bigger than your Macaulay duration. And you can see that in pretty much every single problem. Assuming a positive yield to maturity. If it's negative, why are you investing in the bond? I don't know. But, yeah. That's how you do Macaulay duration. Hope that cleared things up a little bit. Yeah.